mathematics. Okay, so we're going to apply the trig functions. Like I said, today we'll do it on paper. You get some practice there, and then we'll go outside tomorrow and in the building. You can measure, some people call this indirect measurement. Because you're not actually using a tape measure to measure a really tall object. Okay, you're using your trigonometric knowledge. Okay. The tool, if you are actually doing this, is called a clinometer.
Oh, what?
Clinometer. You know, like incline? Clinometer, inclinometer. I just dropped the in for some reason. I don't know why. Okay. It measures angles. So that would be the tool you would use. Versus horizontal angles, the transit, which I'll show you how to use. You can actually use one of those to measure distances. Okay, so let's say you want to measure the height of a really big building. Right?
Yeah.
A really big building. You have no idea how tall it is because you're really small. Welcome to art class.
Right.
How tall is this person?
Pretty darn tall.
8 feet 5.
He's this size.
Okay, so
8 feet 5 inches.
Goliath just showed up today.
Hunter.
He's 8 feet tall. That's fantastic.
He 8 feet tall. That's like a record.
You chose it. It's not on me.
Good job.
Okay. Okay, so that's how tall this gigantic person is. Thank you. All right. Let's say this person is standing 100 feet from the building.
Okay.
Because you can measure that distance pretty easily, right? For the tape measure. I'm trying to draw a scale, but okay, let me just put the name dot.
Not scale.
2 scale.
Okay. This guy just happens to have his pocket clinometer with him because he's a math nerd.
Oh, yeah.
And he uses that clinometer to measure what's called an angle of inclination.
Wait, if you don't get on the court and get my rebound. Definitely.
Or elevation.
It's like Sheldon.
Your book, I think, calls it an angle of elevation. Either word. We'll call that 31 degrees.
31. That's one.
Because it never works out to be a nice, perfect angle measurement, right?
Okay.
What is the height of the building?
That's a very confusing question.
Well, do you go from either?
So,
Which you have to use.
so what's your point in saying that?
Use that. I don't know because it's 8 feet, but the eyes aren't like 8 feet.
So at the end, what do we have to add?
8 feet.
Right. So when we do our trigonometric function here, it's only going to give us d. We have to add 8 at the end. Yeah. Okay. So how would I use a trig function to solve for the height of that?
The opposite, or
Yeah. So you got a reference angle. This is. And this one is.
Adjacent.
Okay. So what's?
Tangent.
Yes.
See, I can't remember.
How do I set it up then?
I can't remember.
or the finding sign.
Tangent of
36?
31.
31. It looks like 6 other.
Equals.
Opposite over.
Opposite.
Right.
Yeah.
Okay, solve that.
So you multiply 10 by 31 by 100, right?
Right.
And then it'll give you.
That gives you D, and then does anybody have that info? I made this up without so I don't know what the answer is.
3,100.
No. Tan 31, make sure you're in radian or degree mode, right? Remember that? Times 100.
0.6.
Go to 4 decimal places. 600 what? Okay.
Well, technically it's not. What is that one circle with the line in the middle called? Theta? Theta.
Oh, I made a mistake. That's bad.
No, theta. Or whatever. Yeah. Theta.
60 point,
Theta.
right? Okay. Is that the height of the building?
No.
Okay, what's the height of the building?
68.
Yeah, you gotta add 8, right? So 68.08 feet is the height of the building. Okay. So tomorrow we'll be using our cellular devices to approximate an angle of elevation. Because your device will have a level on it at 0 degrees, and then if you just line a side up the edge of it, it'll give you an angle measurement. And then you'll measure how far you are from an object. We'll measure the highest point in the school probably, and you can do the same math here to calculate. And then we'll look at everybody's info if we have time and see if we can average it up. I've had people say that the building was 5 feet tall.
What?
A little bit off. So, okay, you can also measure distances. Distance measurement, okay, distance measurement is much more sensitive to angle errors. Because the angles, why did that word just escape me? You have to be a lot more accurate with your angle because the precision required. Oh, never mind. I'll just leave it.
Just never mind.
I think it'll become apparent here. Okay. So when you're measuring, okay, let's put this away. When you're measuring a building, you can have a lot more angles, like from 1 to 89 degrees, right?
Right.
Okay, big span. Okay, when you're measuring distance, there's a lot less range there. Okay, so you have to be more accurate because each change will give you a lot more change. All right, let's stop. Okay. I'm losing it.
Should we just quit for the day?
No, we're good. We're gonna make it. No quitter. I'm there's no quitters in this
Face
room.
doesn't say we're good.
Okay, give me an object. You want to know how far away it would be.
Flagpole.
Car.
A
You're
dog.
so unoriginal.
Another person.
Ooh, mine.
That is a nice Ford. What a Ford.
We'll put a spoiler on it. Give us some headlines.
What a Ford.
Exactly.
It's a Honda Ford. It's a Honda. Yeah.
And it's ugly, so we'll go ahead and put a Chevy emblem on it. There we go. Okay. Car.
Where are you going?
Okay, how tall is this person?
9 feet tall.
Okay, let's be realistic here.
18 feet.
6'3".
6'5.5".
Okay, I'll do it 6'3", so you see you have to change that to a decimal.
That's definitely.
I guess you don't have to. We'll take our pick at the end, how about that? Okay, so you take your height, and you have your handy-dandy clinometer in your pocket again, just because you're a math nerd, and you measure the angle of depression. So here's where the card is, right on the ground. This is called an angle of depression.
That's pretty accurate for Joe.
Okay. We'll call it 2.1 degrees, I don't know. So from horizontal,
This guy's.
you look down at the ground where that car is,
Gotcha.
and it gives you an angle of depression, 2.1 degrees.
Gotcha.
So you formed another triangle here.
Yes, sir.
It's just reflected. Okay. Do you know what the height of this side of the triangle is?
No.
Yeah.
Oh, yeah.
6'3".
Yeah, you do. It's right there. Same as the height of the person. There. And we're trying to find which distance. Hypotenuse
Yeah.
or horizontal distance.
No.
We want this one.
Oh, wait.
What are you talking about? He just did the exact opposite of what you said.
What you said. Okay, so you see the triangle set up? Which function are we going to use? Not your malfunction, which trig function. This is the opposite again, and adjacent, so same function.
Is it 2.1 degrees?
Yes, sir.
Why is it so?
Do we need that, their number to be a decimal?
Yeah.
Yeah.
No. So he was 6.0.
How do we change that to a decimal?
6.25?
Yeah, because it's.
Yeah, how'd you get that back?
Because it's a third of a foot.
Yeah.
We're not a third, a quarter of a foot in it.
3 inches out of 12 total in a foot, right? So
Yeah.
it's not always that easy, but you can get there, okay. And then you solve this here. So I didn't show you this last week. Could have. You can just switch these two values, and you get. That's what you end up doing when you do when you do the math. That's what you end up with. So you can skip the intermediate steps. It's fine with me.
Okay.
Anybody have that answer?
Did anyone write that?
Brad's on.
Tangent of 2.1 is 0.0366.
What is it?
0.0366.
Okay. So what's the final distance there?
No, Brad.
20 feet?
My name's
200
I
feet?
have flashbacks.
Anybody?
I have 170.44.
Oh.
170? Okay, that's how far the car is from you.
Hey, 173.44 inches.
No.
I mean, 0.44.
170.44 feet. Okay, that is not in inches.
So you just,
Do you want to change it to inches?
Yeah. No. Why?
How do you change 0.44 to inches?
wait the number.
Times by 20.
You divide.
Well, how did we get, so here's a lesson in inverses. How did we get to a decimal? Divide by 12. How do you get back? Multiply by 12. Okay.
Yeah, because he
5.2.
5.2 inches? Oh, we're back at the same problem. Okay, so it's approximately, since we don't have to worry about accuracy.
175.2. Or that.
170 feet, 5 inches is close enough for this.
5 inches and more.
If you blast the thing with a cruise missile, it's gonna get the car. 0.2 inches. Okay, so those are the two types of calculations we'll be doing tomorrow, out and about. Right? Things like how tall is the building, how big is the parking lot, how long is the hallway, stuff like that. Obviously, this is our tangent is our main function that we use a lot. All right, there is homework. If possible, there's an advanced problem here that could show up on the test. Would you like me to show it to you? Okay. What it does, the advanced problem involves doing this twice and making it a system of equations to measure like the height of a mountain. Okay, so this is a really big one where here we could measure how far we are from the building. Okay, with the system you can't measure that distance, how far you are from the base of the mountain. So we have to use two different triangles. Does anybody not want to worry about that one?
I just don't want to worry.
It's fine if you don't. It's advanced work. If you want to, I will just give you the homework and you're good to go. So if you want to start working on that, be forewarned, this is probably something that you might see. Like probably might, right?
Wait, what?
92?
92, 32.
I am so confused. This is the homework.
That doesn't happen very often. I'm pretty sure that's about the 5th time I've ever done that. Okay, here's the application problem. All right, you got yourself a big giant mountain, right?
Oh, like only. Yeah. Classic
It's not a bush. Okay. Who
Yeah.
are made of dirt?
Don't you know it's a Grand Canyon?
That was a mountain with green on it. Okay, fine. All right. And then, in the effort to increase the diversity of our math lessons, we will make this a brown person instead of a black person. Kind of difficult to make her a white person, but hey, whatever. All right. So, with measuring height, you have to, so the first problem we did, we had to know how far we were from the edge of the building, right?
Yeah.
Okay. Vertical distance. We cannot measure how far we are from the center of that mountain. Right? That's the problem here. So we have to use two different triangles that have two variables in them and a system of equations to solve that. Right? So we'll steal the numbers right from here.
So it would be in the normal triangle to the base.
So the first thing you do, let's call that 36.75 degrees. Okay. Then you move up and do a second measurement. 40.5 degrees.
That is not.
And you moved 1,000 feet. See the two different triangles?
I'm definitely. Yeah, I can pretty tall. That's.
So you take one angle measurement, 36.75 degrees.
Yeah.
Walk 1,000 feet. Take another measurement, it's 40.5 degrees. Okay. The goal would be in the end to figure out how tall the mountain is. Right. So Do we know this distance? Okay, we'll just call it D, right?
Yeah.
So we have the height and the distance from the mountain. So set this triangle up. It's a tangent function with 36.75 degrees. Right? The opposite is H. What's this measurement? It's the adjacent side, right?
Yeah.
It's 1,000 plus D. Right? That's that total distance. So there's one triangle. We have two variables, so we can't solve that problem yet. Okay. Here's the second. Tan 40.5 H over D. Yeah. Okay, because that's all we're concerned about on this triangle is this distance. Okay. So, you with me on the setup? Okay. We are going to solve this system by substitution. I'm going to solve for H. So multiply by 1,000 plus D. We get 1,000 plus D. Right. We solve for H. Okay, all I did was isolate H.
So you're multiplying it by.
I multiplied it by the denominator. Okay. If you're working on the homework, please keep the volume down. This one I'm going to multiply by D on both sides. How am I going to combine those two by substitution to solve a system?
You have.
Anybody?
Can you plug in the second one where H is, because they're both equal H?
They're both H, so we can set these equal to each other. So we have now the H is gone, and we can solve for D, correct? Okay, that's, anybody confused up to that point? Any issues?
No. So when we find the answer, it'll be H.
You'll get D equals something, then you have to plug that D back in, calculate for H. Okay, what's, okay, can I do this?
Yes.
Yeah.
Can I eliminate the tangent? No, that's an illegal move. Okay, don't do it, please.
Yeah, because then it's
Again, you have to, these are functions, so you have to actually calculate them. So use your calculator. What's tan 36.75?
0.7467.
And tan 40.5?
0.8540.
Calculate those values. And now you have yourself a linear equation. Any number of ways to do it. I would probably just do this. What we got? Divide those two values. Anybody? 1.16.
1.14.
Hundreds.
You're too good.
Trying to be funny.
We're trying to be funny, Jerry.
Next step?
So subtract 1,000.
Nope.
Oh.
If those cancel. So 1,000 equals 0.14D. Now, divide by 0.14. Ooh, extended picture. Have that in your often. Survey says 1,000 divided by 0.14 is not 2.
Yeah, the answer.
Okay.
I got 7,100.
That's not right.
7,100?
7142.
Okay, that's how far away from the mountain. That's D, right?
I don't see it.
How do I calculate H now?
Plug it in.
Plug it in where? Yeah, I would probably use this one, this would be easy. So now plug in here. What do you get? $8,000-ish. Maybe a calculator.
I'm just writing all that down.
Close enough.
I can't even remember what we were asking.
What's the height of the mountain? Is that the final answer?
No, we have to add the height of the first one.
Which we don't have.
Okay, so we've had a really big person, well, a really small person. And we'll make it easy. Okay, so mountain height, add 5, right?
Yeah.
All right, so yeah, those are long involved problems. Definitely advanced work.
Yeah.
Okay. But that's a situation that can occur if you can't measure how far you are from an object, but you can still calculate the height. Cool.
And in any normal situation, if you want to know how tall a mountain is,
You just look at a map. Yeah. Or even better, yeah, type it into your mobile device, which doesn't have internet connectivity at that point.
it's when you look at it before you go to the mountain. You do your research.
We do. Unless you don't know that you're actually going to have to go to that mountain.
That's a good point.
I listened to a story yesterday about a guy who was abandoned in the Brooks Range of Alaska. He survived 200 miles from the haul road. They had to walk out, and it's like this time of year, and it is not warm. It's very snowy. Seriously.
Wait, so how did you
Let me shut this down. We'll get it. There's stories I have if you want.
Yeah.